Okay guys, let's talk a little bit about the homework problems that you have to do for the skill set in Chapter 5. These start out with some matching items, and you notice this is one of the rare cases in the book where some matching items are in the apply and analyze section. And I did that because I know these are hard. And you can refer to the choosing a probability model document that I put up on Moodle for you. I think that might be helpful for these matching questions. Let me talk about a couple of them. Let's talk about this second set where you're supposed to look at volumes of drinking waters carried by hikers and days of the week that hikers on the Pacific Crest Trail were born, number of hikers who reach Scott Falls in the next hour. Of the next 30 hikers, how many will be female, times of day at which watch is lost by hikers, run out of power and stop. So in every case here, you're just trying to figure out what kind of distribution this should be. And the advice I give in that handout is start by deciding whether it's discrete or uniform, or discrete or continuous, and then look at some of the other characteristics to pick a model. So when you do volumes of drinking water carried by hikers on the Pacific Crest Trail, think about volumes. Okay, this is going to come out in gallons or ounces, something like that, liters, okay? And if you think about it, it's not just going to be 1 liter, 2 liter, 3 liter, it can be 1.72 liters. So it's a continuous random variable. And then if it's a random variable that's evenly distributed through a range, it could be uniform, or if it's one that's got a particular central tendency. I'm guessing that if you looked at this for 1,000 hikers, that maybe there'd be this average of 1.2 liters or something like that with a fairly symmetric distribution around it. So that's why I think this one should be a normal probability distribution. So the answer for that one's going to be D. And similarly on all of these questions, go through that kind of analysis. Of the next 30 hikers reaching Scott Falls, the number who will be female. So that's a random variable. You could sit up by Scott Falls and count how many females show up in hours, and sometimes there'd be 0 of them, and sometimes there'd be 10 of them, but it would always be a whole number. So this is a discrete random variable. And if you think about it very hard, it says of the next 30 hikers, that's actually 30 trials, 30 Bernoulli trials. So I said sit for an hour. It's not how many show up in an hour, it's how many out of the next 30 hikers. So I guess the possibilities are 0, 1, 2, 3 through 30 could be female. And every time a hiker comes over the hill, you have a dichotomy, female or not female. And basically this is binomial because it's 30 trials, it's a fixed number of trials, and every time there's a fixed percentage of success. There's a particular proportion of hikers on the PCT that are female. Okay? So think through those in that sense. I know those are demanding problems. It's worthy of your spending some time doing the process of elimination, and then you'll apply this later because I think some of these scenarios come back later in the homework. You get here a probability distribution that's just an empirical distribution where you know the probability distribution of number of televisions in households, and you figure out the mean and do a couple of other things with it. Let's see. I think there's a problem down here about finding the mean of this distribution of multiple births. What's the probability that the next delivery in the US will be quadruplets? Well, here's the probability over here. And when you interpret the mean of that distribution, is that question over here on the facing page, it says find and interpret the mean. Just make sure you put a unit with that. What's the unit on that mean? And I think that'll allow you to figure out what it means. Let's look at 28 and 29. I hope you're not confused by this. I think in number 28, that's a self-contained problem. 29, the picture here applies to number 29, not to number 28. So up in 28 it says, suppose x is a discrete random variable taking values 0, 1, 2, 3, or 4. It's not the picture. It just takes one of the values, 0, 1, 2, 3, or 4. And it's a uniform probability distribution find the probability that k equals 3. So this one just has 0, 1, 2, 3, 4, and it's a uniform, discrete probability distribution, so the bars are equal height, right? 1, 2, 3, 4, 5 possible outcomes. They have to add up to 100%. I guess the probability of each outcome is 0.2, right, to make that happen. And you can use that picture to get the probability of event 3. I guess you've got one of the answers right here. And it also says find the mean. Just do that with the general formula, sum of k times pk. And then in 29, you've got this continuous random variable. It's a rather strange one. It's got a probability density curve. It's this diagonal line with the algebraic equation y equals x over 8. And remember from your algebra class, think mx plus b. This is just 1/8 times x plus 0. So it's got a y-intercept of 0 and a slope of 1/8. This isn't, the y-axis isn't scaled the same way as the x-axis. When you go over 1 unit, you go up 1/8 of the unit. Okay? And it says show that the enclosed area is 1. Area of a triangle, 1/2 base times height. So you use that to find the area of that sucker. You can figure out this height by figuring out the y-coordinate of that point. And then 30 continues with that same scenario, and it says, okay, so with that picture, how would you define, find the probability that x is equal to 3, that it's between 0 and 3, that it's between 0 and 3 including the endpoints or excluding the endpoints, or that it's greater than 3. Well, just think about drawing a picture or a drawing or a shaded area here for each of these guys. The probability that x is equal, say, is between 0 and 3, come over here, your picture is going to look sort of like this. Let's see, 4, 3. You've got to come up with this area between 0 and 3. So you can just use an area formula for a triangle to find that area. Okay? And then in the next question it says, so you do that for probability that 0 is less equal x is less equal 3. And then in the next part, that's B. In part C it says, what's the probability that it's strictly between 0 and 3, not including the endpoints? Well, in a continuous probability distribution model, the probability of landing exactly on 3.00000 forever is, in theory, 0. That's the part above here. Probability x equal 3, the answer there is 0. And for that reason, there's not going to be a difference between these answers, right? These are going to be the same value. Part D, I think, when you draw the picture, you're going to get a trapezoid. But there are a couple of ways you can figure out that area. Draw the picture and go from there. Let's see, what else in the early running? These are relatively easy because they tell you this is a Poisson distribution with mu equal 2.4, a binomial distribution with n equal 5 and p equal 0.8. So you know the distribution, and it's kind of a practice with your calculator to go in there and use second distribution Poisson PDF or binom PDF. Okay, I'll get out of here and I'll make another video for some of the later problems.